Hello everyone, in this video I'm going to discuss the parametric differentiation. So here we have the example, given x is equals to t over 1 minus t and y is equals to 1 plus t. Find the first derivative in terms of t. Hence, determine the values of t such that the first derivative is equals to 1. So now given that we have x is equals to t over 1 minus t and y is equals to 1 plus t. So now I'm going to differentiate the x with respect to t. So given that it's a rational function, so I'm going to use the quotient rule to answer the questions. So let us differentiate the x respect to t. So dx dt is equals to v, so which is 1 minus t. Next, we have u prime, meaning that I'm going to differentiate the t, so we will have 1 minus u. So in here, u is equals to t, multiply with v prime. So meaning that we are going to differentiate 1 minus t. So we will have negative 1 over v squared, where v is 1 minus t bracket square. Simplify the situation. 1 minus t minus expansion, we will have plus t over 1 minus t bracket square. So finally, the dx dt will be equals to 1 over 1 minus t bracket square. Next, I'm going to differentiate the y respect to t. Differentiate y, we have dy dt equals to 0 plus 1. So we have dy dt is equals to 1. So next, we are going to find the dy dx. So by using the chain rule, we have dy dx is equals to dy dt multiplied with dt dx. So what we have to do is to substitute and flip the situation. So in here, the dy dt is equals to 1 multiply with dt dx. So in here, we have dx dt. So in order to get the dt dx, we have to multiply with 1 minus t bracket square over 1. So finally, the dy dx will be equals to 1 minus t bracket square. So now we are going to find the value of t. So we will have 1 is equals to 1 minus t bracket square. So next, I'm going to expand the situation on the right hand side, and we will have 1 minus 2t plus t squared, which is equals to 1. So rearrange the situation, and we will have t squared minus 2t, which is equals to 0. So kindly factorize the situation. So we will have t bracket t minus 2, which is equals to 0. So in here, t will be equals to 0. T will be equals to 2. So now we are going to evaluate the second derivative for the values of t in part A above. So previously we already defined or determined dx dt is equals to 1 over 1 minus t bracket square, and the dy dt is equals to 1. Finally, the first derivative is equals to 1 minus t bracket square. So now we are going to find the second derivative for the parametric differentiation. So the formula for the second derivative would be second derivative is equals to differentiate the dy dx with respect to t. Then we have to multiply with dt dx. So now we are going to differentiate the dy dx. So in order to differentiate the dy dx with respect to t, so we have 2 bracket 1 minus t to the power of 1 Differentiate the internal function, which is 1 minus t, with respect to t, so we will have negative 1. Then do remember to multiply with dt dx. So meaning that dt dx will be 1 minus t bracket square over 1. So finally, we have the second derivative is equals to negative 2 bracket 1 minus t to the power of 3, because by the using of the law of indices, 1 plus 2 will be equals to 3. So now we are going to find the value for the second derivative of t in the part A. So first, when the t is equals to 0, if we substitute the value of t, we will have the second derivative equals to negative 2. When the t is equals to 2, then the second derivative will be equals to, if we substitute the 2 in here, we will have negative 1. Negative 1 power 3, we will still have negative 1. Multiply with the negative 2, so finally we will have the second derivative will be equals to 2. So here we are, and thanks for watching.